But I will switch over to slides. Hey everyone, I'm Eric, and I'll wait for Riaz to switch over to my slides. A little bit about me. I've been a full-time developer for about a year and a half now, so not a lot of time, but enough where I've learned a lot, and I think I've can now take some of those learnings and present them to you, and hopefully you gain something as well. So let's get started. So you've deployed. Well, how is your app performing? All right, just some brief context. I'm going to do a little plug for my company as well. So I work for a company called Genesys. We do contact center as a service software. So for all those that are confused, basically when you call in to say like a 1-800 number, or you want to get in contact with a customer service representative for another company, you'll probably be doing that through our platform. So we provide the servers and the software in a cloud solution so that you can handle your conversation with one of those companies' agents, and then it gets routed through our platform. And that's our high-level architecture. I thought this is a tech event, so let's show the high-level architecture. These squares here are the things that my team works on. Basically, we handle everything after the call takes place. So for like, say, compliance reasons, we want a recording so that we can say in 5 years, like if there's some sort of legal dispute, but also to improve how the agents are performing on our platform, to give them feedback, evaluate their performance, and then even feed this information into AI tools to give like summarization and sentiment analysis. Okay, now let's go back to our talk. How is your app performing? Oh yeah, one last thing is all that information, all that interactions within our platform generates a lot of data. We have, I believe, over 1 million agents on our platform, and so that's a lot of data being generated. Okay. Oh yeah, and I've also given myself a couple of challenges. So a lot of artists like to have constraints put on their work. So for me as an artist, I'm gonna not show any code in this presentation. And I'm doing that because often like you forget the code as soon as you see it, and it's not that memorable. I'm also gonna stick to 3 concise points. So let's go over those points. Number 1, shorten your feedback cycles. This is very important in the developer process. Number 2, using telemetry. That is what my talk is about. And number 3, to improve your application's performance. All right, let's get started with shortening our feedback cycles. And I'm gonna start with a short story. So, say you're a developer, and you have this great idea for a side project, something you're gonna do late at nights that you're excited to spend all your time on. It's a grocery management app. You wanna know what's in your fridge so that it can instantly go on your grocery list. So the next time you're at the store, you don't forget to pick up your eggs, and then your partner is really upset at you when you come home and you don't have the eggs. So you spend all night making mock-ups with pencil to your phone, and you have a great idea, so let's get going. And you spend all your weeknights coding because you're super excited about this product. And finally, the day comes where you ship your product. But that's just the start of the story. You've deployed. How is your app Is your app working as expected? And how can you get the fastest feedback? And is anyone actually using it? Like seriously, like it's pretty hard to get users for your application. Like most people just don't have the time. They don't care. How is it going to improve their life? Anyways, when you deploy, especially as like a small team, as a startup, as a side project, you don't have the resources to test. So you're going to end up testing in production. It's an inevitability. But it's fine because you also don't have that much cost. Like if something goes wrong, if there's a bug in your app, maybe you'll lose your user, but you're not going to lose a large contract or have sort of, some sort of downtime payments that you're going to have to send back. So you want to shorten your feedback loops and reduce how much time so anyways, we're getting stuck here. So you want to shorten your feedback loops. Why? Because it will help you improve your app quickly and improve because it's going to be buggy at the beginning, all right? Okay, so here's an example of feedback loops. And this is actually going to tie in later to our telemetry discussion that comes out slightly later. So I'm a bit of a space nerd, and this is a Hubble Space Telescope. It's been in the space for a couple of decades now, I think. And it's used to take photos of the night sky, specifically faraway galaxies. In fact, there's another space telescope that's now replaced this one, kind of. But something you may not know is, like, how does it work? All right? Like, if I'm an astronomer and I want to point it at a specific part of the night sky, I know that any slight variations in the movement is going to ruin my photo because we're aiming so far in the distant future. Well, actually, you are aiming in the past, not the future, if you know anything about space. So how does the Hubble Space Telescope do it? It uses a gyroscope. Now, this is not the actual gyroscope that the Hubble Space Telescope uses. It's actually from apparently X-15 aircraft. But it gives you a good idea of what a gyroscope does. It manages it basically is an instrument for measurement. So you can get the pitch, yaw, and roll, or basically the angles of degree. And so when something affects the space telescope, say there's some sort of solar winds, or the gravity pulling it towards Earth, it can use the gyroscope to provide feedback to correct the angle. And that's where we want to emphasize, is feedback, right? So specifically how the Hubble Space Telescope does this, and I'm going to be a bit nerdy here, and I'm sure most of you won't get this, is something called a PID controller. And I'm only bringing this up because I studied electrical engineering, and now I do software. So I wanted to at least be able to bring up some of the knowledge I learned during my degree. So essentially, all you have to care about is that it's providing feedback. And if you look at the bottom graph, you can see it's like this wibbly line, and it goes towards a steady state as the time approaches. Essentially, you want that wibbly line to be as quick as possible so it reaches that steady state. And if it overshoots because you're providing too much propulsion, then you want to be able to quickly correct based on our error signal. All right, if y'all aren't confused yet, let's try something more simple. So this is me juggling bath bombs in a wellness store. I think this is near like St. Clair. So it's a nice area for bath bombs. But what you might notice from this photo, if you're paying any attention, is where my eyes are looking. So my eye is actually looking at the top ball in the arc, right? And I'm looking at that top ball because I need to know when to release the next ball while juggling. And if I were to close my eyes or look towards my feet or look away or someone distracts me, then I'm going to quickly lose control of that juggle because I'm no longer paying attention to the top ball. So once again, this is a great example of feedback. And it also, I can demonstrate my juggling skills. All right, let's move on to telemetry now. That's enough about feedback. Okay, I don't remember what the next slide is. Oh yes, definition. Great. So this is a definition I came up with because I didn't want to bother like going on the Wikipedia page or whatever. But essentially what I'm going to call telemetry is diagnostic information associated with an event. Okay, but what does that mean? But essentially, when you say click a buy button on a website, you know it's going to send a request to the backend server to actually buy that item. But there's a lot of information that's generated from that purchase. So what else can be generated from the clicking of a buy button? Well, say something goes wrong or a request is taking too long and something times out in the back end, but then there's a retry or something and then it works. Well, that additional information that there was a timeout could be useful because maybe your app is a little too stressed and you want to improve the performance. Another thing you might want to consider is, well, what products is the user buying over time, or have they bought this product before, or a whole bunch of other things. And then there's, so we'll just click the next slide. And you might also care about latency metrics. So for example, if you click the buy button, and then you have to send the request to a third party to validate the transaction or check the credit card or whatever, and that transaction takes forever, then maybe your user is no longer interested in your website or they're having regrets about their purchase, and then they exit out. If your latency is too bad, you're gonna lose customers. So these measurements are important so that we can improve the quality of our application. And there's some simple and easy ways we can get started that require no additional code. You just throw in maybe an extra script in your HTML head, or you throw in another process that runs in your backend application. So most of you might be familiar with one or two of these. If you've done any web hosting, maybe you've thrown in like Google Analytics on top of your website to see how many visitors you're having to your site, what country they're from, and some other small stuff. For the example I'm going to give, I'm going to use the example of a company called Vercel. Now, they develop software called Next.js, which is a React runtime, or React framework, sorry. And they also provide a lot of other services, such as hosting, and a simple observability web analytics thing. So once again, what you can see here is like what requests are going to what pages. And so from right away, from just these simple metrics, we can get some decent product understanding, right? You can see which blog post is the most popular, and then you understand who are the people that are coming to your blog, and you can write more blog posts like the one that gets the most clicks. That's how BuzzFeed works. Okay, and then you also have a score called, I can't remember what they call it, but they have some patent score, but essentially it's the latency metric. So if your latency is really bad on some pages, it's going to be alerted and your score is going to go down and it's going to look bad. And that could be for a whole bunch of reasons. It could be you just have a lot of JavaScript on that page because you just installed a lot of dependencies or something. Okay, so that's simple metrics, and right away we still get it. Like, it's a decent high-level understanding, right? We now know how many users are interacting with our website. But we might want to know some more detailed information. So obviously when we just deployed, our website's going to be super buggy. So right away, we probably want to get like logs and stack traces as well from the website. So if you're familiar with coding at all, you'll know that when a bug occurs, you get something called a stack trace. And what a stack trace is, it's basically like a map or a list of all the calls that have happened into your functions up until the point of the error. And that can be useful for diagnosing and finding out what things are going on. And so when you have a small application, it's pretty easy to actually just go to wherever your website's being hosted and dig through the logs, or remote into the instance and see what kind of logs you're getting, or throw in some code on your front-end website so you get the errors from what your users are experiencing on the front-end site. And of course, when it's a small app, you can handle that no problem by yourself. But as you start to scale, you might want to consider using a third-party provider so that you can search through those logs. And as well as you scale, these logs will get so overwhelming, and you'll end up having so many charges run up from having all these logs, like terabytes of logs going to third-party platforms, that you might want to consider maybe there's a better way of doing this. But the better way requires code. Okay, now we're at the hard part. Okay, but we're going to stick to the big picture here. So what we want to understand, like the whole point, why are we grabbing metrics, right? It's to improve our application's performance. It's to get a better understanding of what our users are doing. So we don't want all this noise of all these generated logs that just say, like, I don't know, it was just some developer debugging and forgot to remove the logs or something. So how do we get what we want? So we use these aggregate metrics, and I'm going to do a little aside here because I'm going to explain a computer science term called lossy compression. And there's two words there, and I have to explain both of them. So what is compression? Well, compression is actually a lot weirder than you might know. Compression is basically understanding. It's learning. That's what the AI people are talking about now. But essentially what compression is it's like what patterns are in these images. So you can see, like, for example, in this cat, a lot of the color of the cat is orange. So you can just say, instead of saying each square is orange, you can say, oh, only, like, do orange like 10 squares in a row. And it's a pattern. Obviously, it's more complicated than that. But another thing that's involved in this image is it's a JPEG image. So what JPEGs do is they do lossy compression. So the one on the right is actually a more compressed JPEG. And you can tell that kind of in the slides, but essentially it's more blurry, it's more pixelated. But it also means it's a lower quality image. But you can still recognize that as a cat, right? And you can even notice that it's still on a cat bed and it's by the window and there's trees outside, even though it's a lower quality image. So the important stuff that we care about for this image is still represented in the lower quality version. So we can get rid of the high quality. That's basically what I'm saying is like we don't need all the information. I know it was kind of contrived, this example. Okay, so types of aggregate metrics. Okay, please bear with me. Here's where we go in detail. What are count metrics? So say you have that buy button on your web page and a lot of people are clicking it. In fact, in this example here, from periods of time 0 to 1, you had 3 clicks of that buy button. And each of those are represented by an event, a dot on the screen. And although the time is unitless in this example, in this photo I took from the internet, we're going to say that 0 from 1 is 30 seconds and 1 from 2 is another 30 seconds. So at 2, we're at 1 minute, and at 4, we're at 2 minutes. So in the first 30 seconds, we had 3 buys, and at the next 30 seconds, we had 1. And we can aggregate those into buckets of time so that we only get what we care about, because we don't need to know the exact precise timestamp in which the event occurred. We just need to know around what period. And then we can send these stream data points, as they're called, right into a service called a collector. So a collector is something, a piece of software that can be provided by any data solution, metric solution provider. So there's companies like Datadog or New Relic or Sentry, or there's open source software called Prometheus that aggregate our metrics so that we can display them in dashboards and show our manager, and look, we have good latency on our product. But not all metrics are as simple as a simple event. Like for example, another common metric that is faced a lot, especially with dealing with serverless applications, is memory usage. And why memory usage is so important is because you're charged by how much memory you use over time. So we probably want to sample that too. So we can do that with gauge metrics. So we have a continuous form of data, and we can sample that over a period of time and in a periodic way. And we might even have another aperiodic sample just when like conditions are changing up. And once again, these can be aggregated into stream data points, and they can be sent. Okay, one more, histogram metrics. Okay, how's everyone doing? Yeah? Okay, we're following along? Okay, so histogram metrics are like count metrics, except for we have the bonus of we can add another piece of information to them. Typically, this is a latency or a timing metric, but for example, in our purchase example, we might also want to add the price so that we can find the average price of each purchase over a period of time. But sticking to latency, we're once again aggregating these into data points. But since we're aggregating them over a period of time and we have that additional period of information, we right away, when we aggregate them, we can get an average. But the average doesn't tell us full story. The average can actually mislead us on how our app is performing. And I'll get into that a little later. So we can solve that by doing something called buckets. Now, all these, the count, the gauge, the histogram, this is all stuff that you kind of have to implement yourself. So it's important to understand how these work. So when you're writing in your code, oh, I need to know that I want to grab a latency from, say, the first time the user lands on the site to when they make a buy. And that information is important because we might want to optimize to reduce how much time before a purchase happens on our platform. That might be the ultimate metric we're targeting for to improve the quality of our application. Okay, so histogram metrics, a little more. So this is an example of latency, a latency frequency graph. Okay, so let's not be confused here. What does this mean? So this shows us that most of our latencies are about let's say, giving an example of purchases, most of our latencies are between 90 and 100 milliseconds. Or most of our, I'm losing the word. Anyways, what we can do is what we know is we can put these into our buckets. So from 80 to 90, we can have that be a bucket. And then 90 to 100, and that be a bucket. And we can say, hey, for our requests, we don't want more than 100 milliseconds. So when we have that third bucket from 100 plus, what we're actually optimizing for is we don't want more than 100 milliseconds. Now let's give a more concrete example. So like I said earlier, I work in the contact center space. And if anyone's ever called into a contact center, they might have experienced long wait times where you get some lovely music that plays along. Anyways, maybe you've had an experience where that only took 30 seconds, maybe. But the one you're going to remember is the one that took 15 minutes. So even if like the average wait time for our customers is 3 minutes, if there's like 5% that take longer than 15 minutes, by just measuring the average, we're not getting the full picture. We want to reduce the amount of waits that take longer than 15 minutes. And that's why we use histograms. Okay, all that to just improve performance. Great. So we have our metrics. We have a high-level understanding. We know what we want to optimize. But how do we do that? Is it as simple as just looking at them? Like, what are we looking for? We have all this data now. Okay, and I'm going to go back to the web dev world. So there's a piece of software that has recently come out. It's actually a JavaScript runtime. It's called Bun. And it does actually perform like 4 times faster than Node in some examples. So it's handling like about 4.4 times the amount of requests for like the same code. And how is it doing this? How did it get so much faster than Node? I thought Node is like the industry standard. It's what everyone uses. Well, the creator of Node, Jared, said they just kind of profiled everything and saw, well, how can we make this all faster? And by doing this, they came out with a lot faster product. So that's why we want to use telemetry and actually see what our app is performing, or how our app is performing. So let's make this a little bit more concrete. And this is going back to also my electrical engineering days, something more actually computer engineering, but Amdahl's law. So basically, let's say we have a process, and most of that latency is on the server side, but the client is still kind of laggy. Maybe you're using Next.js. So as if you like just took this process and you didn't realize what split it is between the client and the server, you're going to be like, oh, I know. Next.js is like React, and React is like a lot of JavaScript. What if I just like took that out of my application and just used vanilla JavaScript? And that's going to really speed up how fast my client is performing. And you do that, and you get your client to be 5 times faster. But look, your app is still slow. And that's because most of that latency was coming from the server. So if instead you realize that this request was happening on the other side of the world, and if you had put like an edge node just right next to the user instead of spending all that resources optimizing your front end, you could have done a lot less work and only made the server latency 2 times as fast, but the overall application is a lot faster. So what am I trying to share with this example? What am I trying to teach you? Is essentially without knowing the full picture and exactly how the full life cycle of your application and what's causing, you might end up over-optimizing the wrong thing. Okay, and one last thing, this is really a note to myself. Sometimes I get really involved in the code, and I'll just read like on the GitHub of like see how the code is doing. But if I had just run the code, you get to understand it a lot quicker because you can't just simulate it all in your head. So this goes back to our feedback cycles, right? We want to shorten our feedback cycles, and we can really do that by just setting breakpoints. And this is actually really easy in JavaScript. All you have to do is in your JavaScript code, just put the word debugger, and then when it hits that line, it will automatically open up, if you're running in Chrome, it will automatically open up Chrome DevTools. And in Python, you can do that with the breakpoint function, so breakpoint with the parentheses afterwards, like a function, and it will do the same thing for Python. That way you don't have to worry about setting up your IDE, because that's usually the biggest complaint when you're like debugging something. But also logs work too. Like if you're just lazy, you can just put a console.log statement. Anyways, what I wanted to wrap up with, because we've been on a journey together, is that your code can always be better. And this is really a message to myself. But essentially, this is a two-sided meaning. Essentially, you can spend all your time optimizing your code and squeezing the last bit of performance out of it. But then you'll get to the point where your code is really performant, but no one's actually using your application because you've lost track of that and you didn't ship any new features. So you're like an artist when you're writing code. As a painter, you can always add one more brush stroke. But because of the laws of diminishing returns, your art will only slightly get better. So consider that whenever you're profiling your applications. Okay, so to wrap up, shorten your feedback cycles. With short feedback cycles, you can improve quickly, You can get rid of those bugs. You don't have the resources because you're a small team, so you need to have a short feedback cycle. And you need to have that telemetry so you know exactly what's happening in your application such that you can know, like, complete that feedback cycle. And doing that, you can hopefully improve your app's performance. Thank you. All right, questions. How much time do we have?
Make sure to repeat the question.
Okay, sounds good. Hi, yes, you.
Can you go back to the one slide back?
One slide back? Yes.
So is there any computer product to help you out step 1, 2, 3?
Any products?
Yeah, any commercial products?
Any commercial yes, there's plenty of commercial products that help with all these steps. So I mentioned a few in the talk, but I purposely did not put up any on the side. But because it's so dependent, I kept this talk high level, but it's so dependent on what you're working on. So if you're doing like a web developer talk, maybe Vercel's observability. If you've heard of Vercel, they do like serverless deployments for like full stack web applications, Node.js. That could be perfectly fine for you. For actually doing telemetry, there's open source framework called Open Telemetry, and they have their own like collectors and that kind of software, and it's still like mostly, I think it's mostly done now, but it's based off of other software, but like it's all a Google search away. There's software called Prometheus, and then there's the like big solution providers, so like that would be Datadog. We personally use a service called Sumo Logic, another one called New Relic. Obviously, if you're using a cloud provider, they would have their own solutions. So like AWS has CloudWatch, and GCP and Azure have their own as well. Yeah, so any of those can be used for telemetry and help. Yeah, we use them all the time. I spent my whole morning this morning just digging through CloudWatch metrics to track down a bug that we were dealing with, and combing through running log queries. So yeah, it's crucial to what I do every day. Hi, yeah.
Sometimes the histogram can have a long tail.
Yes, exactly.
Long tail behavior.
Yes.
For example, the important components like security
Mm-hmm.
and the latency because of server being longer,
Right.
placed in different places
Yes.
for security purpose.
Uh-huh.
So, and also there are many call stacks. Like this, stack builds up because of different call functions.
Right.
At different server points.
Yeah.
So in those cases, how do we kind of come out with a strategy to optimize it?
Right. Right. Okay. So let me try to summarize your question. So a lot of requests, there's something called long tail effect, and you can kind of see it in this slide here, where you can see there's a taper of requests that happen that are more than 100 milliseconds, and it might continue up to like a 10-second long request or something like that. And how do we optimize for those occurrences of happening? I think it's very context specific, like how many requests are happening and how like important those requests are to your application. A simple thing you might want to do is like throw in a cache, but then your long tail effects are probably ones where there are cache misses. Yeah, it's very context specific. Yeah, I don't know if that answers your question. Yeah. Hey.
So you can have a backend that's composed of multiple services.
Right.
Work in concert.
Yes.
So you can have a request that branches into different
Yes.
services.
Yeah.
How do you correlate telemetry?
Great question. Yeah, so that's something I didn't cover. I think it was even in the description of the talk that I would cover it, but that's called traces. So there's besides logs and metrics, there's something called traces, which gives you a graph of all the different requests if you have a large microservice architecture of the different services that are being hit. And then, so we kind of utilize that, but something else we internally utilize at Genesys is we have a specific correlation ID that's tied to each request. So as it hits each additional service, that correlation ID gets propagated to that service's logs. So then you can search that correlation ID and get all the logs correlated with that request. Yeah.
Fun talk.
Thank you.
The first slide that you showed
Right.
You said your team was responsible for this piece called WEM.
Oh
What is
yeah,
WEM?
yeah. That's I think we sell. Yeah. So WEM is something that's niche to the contact center space. So it's workforce engagement management. So it's everything after the call takes place. So like improving the quality of your agents, giving them feedback. It's also forecasting, how many agents you need for your call volume and for how many interactions you're predicted to get on your platform. So that's all covered under WEM. Yeah. Yeah, sure. One more question.
Correct me if I'm wrong, but I don't think I heard you talk about sampling.
Right.
At what point does one decide to start sampling events?
Uh-huh.
And is this something like sampling even exists for tracers?
Right. Okay. Sampling. I think one thing you might want to do is put alerts. Basically, whenever you get to unexpected behavior, or say like, okay, we want this threshold is appropriate for our software, and then when it goes over that threshold, that's a good point to start sampling. Or you might run like jobs. I'm not sure if that answers your question. Yeah, or if I fully understand what your question is, but does that help?
Maybe.
Okay.
I guess what I'm hearing is like it depends.
Yeah, it's all very, yes. Yeah, but I guess one thing I didn't talk much about in this talk is basically, especially with larger applications, you have like set expected latencies for what is like good for your software. So for example, our team handles screen recordings. So we want our latencies to be short as possible so that when the request comes in, it triggers the screen recording as quickly as possible. So we have really tight latencies there. And if it goes above that certain amount, then we get alerted right away like, hey, something's going wrong. So we need to have correct alerts in our code and in our application so that we can then dig into our logs to see what's going wrong and find what's wrong in our code or in our service. Yeah. Okay. All right. Thank you, everyone.